Today a short video on nucleophilic addition. It should really help you to solve those questions that repeatedly that the exam officers ask every year. So if we look at propanal, and we're going to do the addition of cyanide into propanal. If you remember your shapes, you will see that this carbon atom here, it has got 3 bonding regions around it. So the bond angle is 120 and it's planar. The nitrile, or the cyanide, I should say, the cyanide ion has got 2 options: either to attack this carbon from the front or from the back. So if it attacks it from the back, it gives rise to this 2-hydroxybutane nitrile, and if it attacks it from the front, then it gives rise to this 2-hydroxybutane nitrile. So this one is the R isomer and this one is S isomer. You remember that the solid bonds, if you like, that means it's coming towards us. The dotted ones, it goes to the back, okay, away from us, and the ones that are just one line like this, they are on the same plane as the screen. Okay, so here you have 2 enantiomers. So you have 2 molecules that are mirror image of each other, but that you cannot superimpose. So if you wanted to make this 2-hydroxybutane nitrile, the same as this one, you would need to break those 2 bonds and make the new ones. So if you have to break and make new bonds to make them the same, then that means that they are not the same to start with. Okay? Now, because this is planar, the nitrile has got 50% chance of attacking that carbon from either 50% from above or below. So it gives rise to 50% or an equimolar amount of each enantiomer. And since you would have 50% of each enantiomer, that makes a racemic mixture or racemate, then the product itself would not show optical activity, because one enantiomer would tilt the plane polarized light clockwise and the other anti-clockwise, so they would cancel each other's effect on the plane polarized light. Okay, very important. Now, in your explanations, when you answer those questions, you need to remember that first of all, it needs to be sort of asymmetric. I will talk about that in the next slide. When you've got this carbon here, they call this, so although it hasn't got 4 groups on, it's only got 3, but because it's got 3 different groups on, they call that a prochiral center. So eventually, if you added something to it that would be different from these 2 groups, obviously, you could make it chiral. So they call that a prochiral center. So in your explanation, you need to say that this is planar. Okay, so this is planar. Don't say the carbonyl bond or C double bond O is planar, because that makes no sense. If you know a little bit about maths, 2 points are always in the same plane. Okay, so don't say it's planar, because that makes no sense. don't say that the molecule is planar, because that's not true either. Okay, so if you say these things, you're toast. What you need to say is, this is planar. This is what you have to say. Okay, so this is what you draw in your answer, and then you say the nucleophile can attack it from below or above in equal probability. Yeah, 50% chance of each. So it forms an equimolar mixture of both enantiomers. Okay, so you need to say this. It's not creative writing. You just have to say that verbatim, really. Now, obviously, if you have something that is symmetrical, then this carbon atom cannot be considered as a prochiral center, okay? Because if you add this nitrile group, for example, yeah, to produce this 2-hydroxy 2-methyl propane, then you can see that this carbon atom has got two groups that are the same. So the 4 groups are not different. Okay, so it can't be optically active at all because it doesn't go chiral center. Okay, so that doesn't form a racemic mixture either. Okay, because it doesn't got 2 enantiomers. I hope this helps to answer those questions that I've set. Thank you very much.